everybody, this is Larry. This is me going with Q4 of the weekly contest 252. Count number of special subsequences. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem, and especially if you did this during the contest or if you did the contest in general, come hang out. We usually, just a bunch of smart people and me talk about problems right afterwards. So if you need buddies and hobbies or whatever, come hang out. Okay, so this one is a dynamic programming problem, and to be honest, for me, if you did this during the contest, you can see that I actually solved it pretty quickly, and actually almost quicker than Q2 even. So this is dynamic programming, and the reason why is, and actually a lot of people did it as well, right? In like 2 minutes. I wouldn't say that this is a standard problem, but it is, for a dynamic programming problem, it is something that if you have practiced enough, you'll probably recognize some of it. And the way that I did it is a little bit thinking about cases per cases. And this is an example of, I think, what used to be called suffix dynamic programming. Basically, all you care about is the last number or last digit. And you can actually do this recursively as well. N is 10 to the 5th, so maybe recursion with memorization is probably fast enough. But for me, it's easy to do it, or like I'm way well practiced in doing it bottoms up. And so I'm going to attempt to explain this one that way. But so this is my code. But and I did this in, I actually did the space optimization off the bat because I know that every digit just depends on the last digit. Because I've solved similar problems before, so some of this is going to look like it's cray, but to be honest, I just spent hours and hours and hours and hours and hours and hours in the past, right? So definitely, don't be intimidated, especially like you could watch me solve it live afterwards, and you can kind of see me jump right into this, even though I had some issues. But yeah, but it's about determining the base cases and determining how to think about how to enumerate them in a good way. And here I actually even did this a little bit yucky. You can actually make this into you could simplify this code with a for loop or something even easier, but this is as explicit as I get. So yeah, so basically at every point dp contains the number of special subsequence where the last digit is dp sub I, or I guess dp sub I contains this, and pdp sub I contains the number of special subsequences where the last digit is d sub I. How do I want to phrase this? So yeah, where the last digit is the last digit is I using num sub using the prefix of the using the first I numbers. Maybe that's a little bit clearer. Where the last digit is using the first I numbers as well. I minus 1 numbers. Right. So from that, we think about the base case, and in the case of 0, and this is how I start with this is actually, when we kick it off, this contains zeros because there are no subsequences of any length or of length 0 that is special, right? And in this case, then we just enumerate through the things. We start this off at 0, and then okay, if this current number is 0, what does that mean? That means that that, okay, we just literally go through it case by case. If this is a 0, that means that we could start that means that this hides a lot of math, but basically what it's saying is that, okay, so PDP is the number of special subsequences where the last digit is 0, using the previous numbers or previous numbers, right? So when this is the case, then given it's 0, what happens? Well, you want to, let's say PDP 0 is equal to 5, right? What does this mean? That means that maybe 5 is not a possible number, actually, to be honest. But let's say I don't even know if 6 is right, but 6, right? So it doesn't matter what the actual subsequence is. I'm going to make up something up, but you could imagine that, there's a 0, there's a 0, 0, there's another 0, 0, because maybe there are 2 different zeros, because if you have 3, actually, I think this is right. So basically, let's say sequence is 0, 0, 0, and then these are the possible previous numbers, right? Okay, this is previous sequence. Current digit is 0, and then in that case, there's 6 of these, and then you ask, okay, in this case, what happens? In this case, you can add a 0 to each previous sequence, right? So that means that if the previous is 6, then you could add a 0 to this, add a 0 to this, dot, dot, dot. Oh, I'm not going to actually draw all of them, right? So there's 6 ways of doing that. So then that explains the first PDP for 0. And then what if you don't add a 0, right? Well, okay. Let me step back for a second. So there's 6 ways to do this, to add a sequence to 0. And then there's a +1 way. What's the +1 for? The +1 is for adding to the empty sequence +0. So you're starting a new sequence. So that's basically this contribution. And then, so that's adding this 0 to a previous sequence. So there are this many ways, in the new ways, to add this current number. And then the other one is just skipping the 0. Skip this 0 as a subsequence. And in that case, you have PDP plus 0, 0, right? Because, well, that's just the number of previous sequences. And the number of previous sequences, because we skipped it, is equal to this number. So this is adding the 0 to a previous sequence, and this is just ignoring this and using the previous sequence, and that's how you get this number, right? And then, of course, we just mod it because, you have to remember the mod. And then here, because we didn't touch 1 or 2, this is still, now we just carry it over, right? Because this is the number of special subsequence where the last digit is 1 and up to this point, right? So that's basically the idea. Hopefully this is illustrative. Definitely go over it again if this doesn't make sense, because now we exactly do the same thing, right? For a digit is equal to 1, well, in this case, we go, okay, add 1 to a previous subsequence. And how many are there ways? Well, the previous, you could add 1 to a previous subsequence that ended in 0. So this is PDP of 0. Add 1 to add a number 1, so that it doesn't look like I'm adding 1 literally. Previous subsequence that ended in 1, right? And this is PDP of 1. So yeah, and then skip adding this number 1. The previous subsequence that ended in 1 is this thing, right? Because this is just skipping it. So in this case, we have this contribution, which is the sum of these 3 things, and then you mod it again. Again, the number of subsequence that ended in 0 or 2 didn't change because this is not the number. Then you could kind of, copy and paste at this point, hopefully, to understand, is that you add 2 to a previous subsequence. Well, if you add 2 to a previous subsequence that ended, and you cannot add it to 0, you have to add it to 1, this is equal to 1. Add a number 2 to a previous sequence that ends at 2 is this thing. And yeah, and this thing, as you can guess, is this. So the contribution then is this. And of course, you mod it again. And if you are a little bit confused about why these rows are, this is basically the thing that's here, right? So it has to be positive number of zeros, which is why you cannot have 0 zeros. If you can have 0 zeros, then this would actually add in, because you can add a 2. You know, you could use a 2 to stop a 2. Maybe we'll, do a little bit of a practice explanation of, okay, let's say this is no longer positive. This is, you could use 0 number of zeros or 0 number of ones, right? If you could do that, then you also have a sequence where add a number 2 to a previous subsequence that ended in 0. So this is just PDP of 0. Add a number 2 to a previously empty subsequence. Like, you could basically start a sequence and this is 1. And so if you're doing one where you do not need to go from a 1 to 0 or so forth, you would just add this to the number here. And of course, mod by mod in the end. So just to kind of give you some examples about how to think about this thought process. Yeah, and then the question at the end is how many special subsequence you have, right? And the subsequence will have to end in 2s. So then now, building off that, it's just dp of 2, because that literally means the number of subsequence that ends with 2. And then you do it by mod. Oh, sorry, mod by mod. And that's basically it. As you can kind of really, you could see this quickly. This is linear. This is linear time, because we're just literally going through the end, like one number at a time, and just having a couple of if statements and add and mods. And of course, this is constant space, because as you can see, we have 2 arrays of 3 elements each. I know that technically speaking, I do construct new elements because I'm lazy, but you can use a for loop to clear the previous element if that was the thing, and then set it and clear. Yeah, that's just like quick semantics. But yeah, that's all I have for this one. Linear time, constant space. Let me know what you think, and you can watch me solve it live during the contest next. AC as an AC. Okay, let's see. How number of special subsequences. Okay. Positive number of 0, positive number of 1, positive number of 2s, for example. Return the number that's special. Okay, what does that mean? This should be okay. This is actually easier than Q3 if you ask me, because this is just straightforward dynamic programming. By positive number. Okay, so it has to be all positive. This is, yeah, okay. Okay, I mean, this is relatively straightforward, maybe. At least for me. I mean, okay, maybe that sounds like a brag. I just mean, like, I've seen similar problems before. Okay, mod. Yes, okay. I have to sing the mod song because otherwise I keep forgetting about it. Okay, mod. Okay, and then now, okay. Let's just write it out. I think it can be a little bit smaller, but I am not going to be that much smaller. Let's see. dp of 0 is equal to previous 0 plus 1 in this case. Is that all the cases? I don't know. Maybe not. Well, I know this is really exhaustive, but I'm just doing it slowly, trying to think. Yeah, I think this should be okay. Okay, maybe. Let's see. We will see. We will see. Okay. If it's 1, then well, plus. Is that right? I mean, I know that I could do some optimization. I'm just trying to see if it at least gives me some directional correctness. For example, this should at least make this one correct, which it does not. So it makes me sad. Sad. Special object requirements. I have 2. Why do I have 2? So this is 1, this is 1. At the end, this is going to be 1. Now the 2 is going to be the previous 2. So 1 plus. Oh, I see it. How do I think about this? So I didn't think about all the cases correctly. I just kind of went pattern thinking about what I've done, but this isn't quite right. So if this is a 2, you can add it to all the previous 2s. There's a multiplier there somewhere, maybe. No. Let me think about this. What does it mean to add a 2 to a previous sequence? So there's 1, there's 2. I think I'm mixing something up, that's why. So this is actually correct, but I think I need to add another 2 for not including it. Because, yeah, I think that's right. Okay, maybe. Is this right? If this is a 0, you could either use it or don't use it. If you don't use it, then it's the previous. If you do use it, then it is the okay. Maybe something like this. Is this right? 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 The thing with testing on this one is that I don't know, like, what the right answer is, right? So testing the cases don't really. So I'm going to YOLO a little bit on this one because I don't think I have a good way of judging. Okay, well, the reason is that I don't think I would have benefit from additional testing, because additional testing, like, I don't know the right answer for this unless I want to spend like 10 minutes to write a brute force one to verify that this is correct. And if I do that, I mean, then, I could verify this, but then, like, at that point, if I'm going to spend 10 minutes, I almost, like, it's a weighted calculation of, I should just, like, if I get it wrong, then I spend a 5-minute penalty, but I also got a test case in which I know the answer, right, to use it as a debug, where if I spend 10 minutes to write, maybe not 10 minutes, but if I write code to verify this, like we write a brute force, this is not I guess it's not that bad. Maybe like a 3 or 4 minute time to write a brute force solution, even if you know what to do. And and you do that math and you think, well, if it takes me 4 minutes to verify and generate a solution and stuff like that, maybe a little bit longer because it takes time to create test cases, etc. Then I just rather get the wrong answer and then kind of, speed it ahead. Yeah, thanks for watching. Hit the like button, hit the subscribe button. Join me on Discord. Let me know what you think about this problem, other problems, whatever you need to do. I'll see you later. To stay good, stay healthy, to good mental health. See you later. Bye-bye.